Good morning, girls. Children, in yesterday's video, I had explained you what is a midpoint theorem and what is a converse of the midpoint theorem. Now, today we are going to start with the exercise 8.2 in chapter Quadrilaterals, and we are going to quickly revise what is the midpoint theorem. See, according to the midpoint theorem, if in a triangle, the line segment, if in a triangle, the line segment joins the two midpoints of the two sides of the triangle, that is equal to that line segment is parallel to the third side and is equal to half of the third side. So I repeat, according to the midpoint theorem, the line segment joining the two midpoints of the two sides of the triangle, it is parallel to the third side and is equal to half of it. Okay. So one more, we have the converse of this, which says that in a triangle ABC, if the line segment, if a line segment in which one point is a midpoint, and it is parallel to another side, it bisects the third side. So these two theorems we've done yesterday, so I hope you have seen the video, and based on these two theorems we have the exercise 8.2. Okay, so starting with question number 1, we have a quadrilateral given. First, question number 1, there is a quadrilateral ABCD in which P, Q, R and S are the midpoints. Okay, now these are the midpoints, so let us join them. Okay, so these are the midpoints. Then AC is also joined. We have to prove, number 1, SR is parallel to AC, then SR is half of AC, SR is half of AC, SR is parallel to AC. Second one, PQ is equal to SR, okay, and third one is PQRS is a parallelogram. So these are the three parts which we have to prove. Now it is given that to prove, now given ABCD is a quadrilateral and these are all midpoints, so you can write the given conditions. Now you know that if we take this triangle ADC, right, in triangle ADC, since S and R are the midpoints, so therefore what will happen, this line segment will be parallel to AC, it will be half of AC. So we can write in triangle ADC, S and R are the midpoints of the given sides. You can mention the sides also. Therefore, SR is parallel to AC and it is equal to half of AC. Which theorem? By the midpoint theorem. Correct? So this is number 1. So that these are midpoints, therefore we can apply this midpoint theorem. Now similarly in triangle ABC, yes, in triangle ABC, same, P and Q are the midpoints of the given sides, therefore PQ parallel to AC and PQ is equal to half of AC. Yes. Now when you compare these two, SR is parallel to AC, PQ is parallel to AC, SR is half of AC, PQ is half of AC. So when we compare these two, we can write, therefore by 1 and 2 we can write SR is parallel to PQ, okay, and SR is equal to half of AC, PQ is half of AC, so therefore SR is equal to PQ. Okay, so you've understood what I'm saying. Now we'll write, therefore when you compare these two conditions, children, you will get opposite sides are parallel, opposite sides are equal, So therefore we can write PQRS is a parallelogram. Now, so what is the first thing we have to prove? SR is parallel to AC, done. SR is half of AC, done. PQ is equal to SR or SR is equal to PQ, done. And since opposite sides, you will mention the reason. Since opposite sides are equal and parallel, therefore what? PQRS is a parallelogram. So this question 1 complete. So easy it is. We will now solve question number 2. Question 2 says that ABCD is a rhombus, PQRS are the midpoints of the given sides. Show that the quadrilateral PQRS is a rectangle. So the figure will be similar to this. Okay, same figure. Okay, we will take number 2. We'll write given quadrilateral ABCD. No, not quadrilateral. ABCD is a rhombus. Okay, now since it is a rhombus, you know that all the 4 sides will be equal, and these are the midpoints. So when ABCD is a rhombus, AB is equal to BC is equal to CD is equal to DA. Now we also know that PQRS are the midpoints of AB, BC, CD and DA, right? What? To prove PQRS is a rectangle. Now if we prove that PQRS is a parallelogram with one angle equal to 90 degree, then we can say that PQRS is a rectangle. Understood what I said? If I first prove that PQRS is a parallelogram, and then if I say that one angle is a 90 degree angle, then we can say PQRS is a rectangle. So before that, we have to join. Now the construction is AC is not joined, we will join. So let it be a dotted line. Okay, now similarly, join AC. Now, like what we've done in the previous question, same we'll do here also. In triangle ADC, yes, SR is parallel to AC, SR is equal to half of AC. And why? Because S and R are the midpoint. So you will write it down. I'm only writing these conditions, but you will write the proper reasons. So in triangle ADC, according to the midpoint theorem, SR is parallel to AC, SR is equal to half of AC because S and R are the midpoints of these given sides. Okay, number 1. Similarly, in triangle ABC, same, PQ is parallel to AC, PQ is equal to half of AC. Same thing, this is 2. So by 1 and 2, we will get SR is equal to PQ and SR is parallel to AC. Now why? Because if SR, not AC, sorry, PQ. So since SR is equal to PQ, SR is parallel to PQ, therefore we now know that PQRS is a parallelogram. So this is the same proof what we've done in the first question. Now since PQRS is a parallelogram and we have to show that PQRS is a rectangle, so if we show that this angle is a 90 degree angle, so PQRS will become a rectangle. Now how can we do that? Let us number the angles. 1, 2, 3 and 4. Okay, so I hope this part is clear to you. We now go to the next part. We know that in a rhombus all the 4 sides are equal. Yes, so we can write, now since this is after completing that PQRS is a parallelogram, we will start with this part. Now since AB is equal to BC, yes, therefore half of AB is equal to half of BC. What is half of AB? PB. What is half of BC? BQ. Now when you have got PB equal to BQ, these two sides in a triangle are equal, therefore this angle 2 will be equal to angle 3. So therefore angle 2 is equal to angle 3. What is the reason? Angles opposite two equal sides are equal. Now children, what are we trying to do? We are trying to prove that this angle in between is a 90-degree angle. Okay, so this completes your, this is first part. 2 is equal to 3. Now if I take if I somehow prove that APS and triangle RCQ, they are congruent. Okay, we will take this part now, so we can now solve. Next, in triangle APS and triangle CQR, can we say the lengths are equal? Like AP will be equal to CQ, yes, and yes, and what, AS will be equal to RC, because these are all halves of the equal sides, and we know that PS is equal to RQ because it is a parallelogram. So therefore these two triangles will be congruent and one will be equal to 4. Okay, so what we'll write now, in triangle APS and triangle CQR, AP is equal to CQ. Okay, AP is equal to CQ, halves of equal sides. Then AS, can you see? AS is equal to CR and PS is equal to QR, opposite sides of parallelogram. And why do we write AS is equal to, again, halves of the equal sides? Because all the 4 sides are equal, so the halves will be equal. Now triangles are congruent by SSS. Now when the triangles are congruent, we can write angle 1 is equal to angle 4. Now here we've got 2 is equal to 3. So let us number this equation as 3, because in the previous part we have numbered it as what? 1 and 2. Let this be 3. Let this be 4. Okay, so I hope this part is clear to you. We have already proved that 2 is equal to 3 and we have now proved that 1 is equal to 4. Now let us take these 3 together. Let this be 5 and this be 6. Okay, now we write angle 1 plus angle 5 plus angle 2 is equal to 180 degree. You know what? This is forming a linear pair. Yeah. Similarly here, 3 plus 6 plus 4 equals to 180 degrees, same. So when you compare these two, you will get angle 1 plus angle 5 plus angle 2 equals to angle 3 plus angle 6 plus angle 4. Now 1 will cancel with 4 because they are equal. 2 will cancel with 3. Now we are left with 5 is equal to 6. Now 5 is equal to 6. Now we know that PQRS is a parallelogram. So when the in a parallelogram, adjacent angles are supplementary. Now these are adjacent angles. Okay, so we write in a parallelogram, or we write PQRS is a parallelogram. Therefore, angle 5 plus angle 6 will be equal to 180 degree. Reason will be adjacent angles are supplementary. Now you know that 5 and 6 are equal. So we can write angle 5 plus angle 5 equals to 180. Twice angle 5 is equal to 180. Therefore, angle 5 is equal to 90. Now, if this angle 5 is 90, 6 is 90, then this is 90 and this is 90. So, now we know that PQRS is a parallelogram. So, the final statement will be, now since PQRS is a parallelogram with one angle equal to 90 degree, therefore PQRS is a rectangle. So, we'll write therefore. Now write since, not therefore. Since PQRS is a parallelogram with one angle as a right angle, therefore PQRS is a what? A rectangle. So this completes your question number 2. So 1 and 2 we have completed, and total children there are 7 questions. Question number 3 is ABCD is a rectangle and PQRS are the midpoints of the sides AB, BC, CD and D respectively. So figure will be same, but the only thing is ABCD you will draw it as a rectangle. Now you have to show that the quadrilateral which is formed by PQRS is a rhombus. So today you will solve this. This is your homework. Complete first and second. Try the third one. Tomorrow in my video I will explain the next questions. And I hope you are doing your all your pending work you have completed, and you have completed this midpoint theorem also. If you know what is a midpoint theorem and the converse of this, then you will understand this exercise. Okay, and if you have any doubt in these 2 questions, you can ask me. Okay children, thank you. Have a good day.